So now we're going to talk about linear regression. When we talk about linear regression, we are trying to create the line that is best fit to the data. So looking at this positive correlation that we had from another video, we said it looks like it is increasing as we move from left to right in a fairly linear manner. We found the Pearson's R coefficient, which was close to 0.9, and at the 0.5 level of significance, we said yes, yes, it's got a good correlation, and so we can find that line. So then the next question is, what do we mean by best fit on the line? Do we try to pick a line that goes through the most points? Maybe here, maybe I could go here and hit a couple. Where is that line that fits what we would consider best? When we are creating this line that is best fit, we're using what's called least squares approximation. We, in theory, say, well, we'd like to be as close, draw the line where we can minimize the distance between the line and the actual points. So if we look at this distance here and this distance here, and the difference in those y coordinates, we can create lines where that distance is always 0. However, it's not always the best fit. So what we do is we find all of those distances and we square them. Okay, that way everything is positive, and then we want to make that positive number as small as possible. Okay, now we're not going to derive that formula. We're gonna go with what we're told. Creating these formulas that we're going to give are outside the scope of our class. So we have to trust that that the experts know what they mean when they give us those formulas. So since we're talking about straight lines, we know from college algebra, when we look at the equation of a line, that we think about it as y equals mx plus b, where m is the slope of the line and b is the y-intercept. Didn't type that, but b is the y-intercept. Okay, which is where it crosses the y-axis. Now, when we're doing statistics and we're talking about these squares, regression lines, then B's flip-flop, so that can be confusing. And I don't like it being a math person, but those are the statistics rules. Okay, we call our equation, instead of just a plain old y, we call it y prime. Y prime means when we see a y prime on there, we know that we're estimating, okay, or approximating. I can't write one word and say another. Estimate or approximate. Okay, so it's not a perfect line that's going to fit through all of our points, but this is going to be our best fit line. And A is the y-intercept, and B is the slope. The rules haven't changed from college algebra, it's just that we write the equation in a different order. Now the formulas for A and B are kind of nasty. Well, that's fine too. Okay, A and B are kind of nasty, but the good news is they use all of the same values that we had to use when we were finding Pearson's R and going through the other stuff that we've already done. From our data values, we should have x squared columns and xy columns and y squared columns and the like. So we don't have to find any new values if we've kept our data as we're progressing through the problem. So let's come back to this example with the dollar amount that's spent on recreation versus the income. We said it looks like a straight line. We, with our hypothesis test, said sure it is. And so that went the wrong way. So now let's write that equation of the line, our line that's best fit for our data. Let's go with black. Okay. From the column, and I don't know, I think I can scroll down here. Yep. To get our A, if we cut and paste the values from the table that we have from our Excel spreadsheet, this is a mess, but we can copy and paste them into the formula. If you're still getting confused about the difference between the sum of the x squareds and the sum of x's, that quantity squared, give me a shout. I can try to help you get that straightened out. The nice thing about the denominator between a and b is it's the same. So if we want to, our calculators can hold all of these values for us if we type in the grouping symbols correctly. But if we want to break it down and go a piece at a time, then we can find the top separate from the bottom and write those down. If you want to pause the video and try to get this stuff typed in, that would be fine with me. I'm just going to roll through this one and give you time to pause, more time to pause on the other example. Hopefully I didn't transpose anything. Now remember, A is our y-intercept of our line, so it's going to cross our y-axis 222.5 units below the origin. If I want to find my B, again, the denominator is the same for A and B. Okay, 7 values total, 7 ordered pairs. My 854 number, sorry it's not very legible here, but you can see it from the other page if you say what is she writing on that whiteboard. This b is a positive value. We know that the slope should be positive. If our line is increasing, we had that positive correlation coefficient of almost 0.9. So make sure you end up with a positive slope here. That says 355. Okay. So if I want to write the equation for the regression line, that is the quote-unquote best fit line for this data up here, it would look like y prime equals negative 222.493 plus 0.355x. I have my Desmos plots. I didn't label them this time, but I have the line ready to plug in. And so if you look at a picture of that line, it is not, again, it looks like it comes really close to passing through this one here, maybe even closer to passing through that one, because we're in the 800s and 900s, and the way our scale is, it's not going to go exactly through those points. Look, it comes very close, but it doesn't actually pass through them. But when you draw a sketch of the graph in amongst your points, then it should look reasonable. Okay, when I typed this into my calculator the first time, I didn't hit the squared button before I hit equals on one of them, and I ended up with some line that went off this way down here. So I immediately knew something was wrong, and I went back to find my mistake, and it was user error entry on the calculator. Okay. So let's look now at our negative regression line. Okay, I want you to pause the video here in just a moment. We did the hypothesis test. We said this is very near a straight line, and it passed our hypothesis test, or it failed, however you want to say it, but we verified that there was a correlation. And so go ahead and pause the video and find that line for me, please. I'm going to do the same. Okay, so when we plug in for the A, we've got our sum of y's and our sum of x squareds, and down here is the sum of x's squared, and so on. And so it looks like our y-intercept is real close to 97. For our b, that's supposed to say 53. That up here is supposed to be a 4. We should get the slope as negative 0.45. So our regression line looks like 96.784 minus 0.453x. I'll pause the video again and hop over to Desmos. We'll show you a picture of that. Okay, so when I graphed the line, it went through like this. and I'm not convinced that I'm completely correct, but if you find where my mistake is, then please holler at me. Maybe you don't see a mistake in the work that I've done, um, but looking at this line, I'm not convinced that this is the best fit line. So, but my video's gotten long enough, I need to stop it and go on to the next one. So again, give me a shout if you see my mistake, and if I find one, I'll sure post it in the next video. Katie.